Welcome to this Blender 2.8 tutorial for tabletop wargaming. I'm Jason, the creator of the Tabletop Battlefield. This is our project right here. I got to make sure all the trees are standing straight. One fell over during the last intro. But anyway, what we're making today is a 3D printed forest base for Woodland Scenics Trees. So let's get started. Here we are inside Blender 2.8. This is a fairly recent version of the beta compared to what I've been using, but let's get started with the modeling. And by that, I mean let's delete everything. Press B for box select, select everything, hit X, and then choose delete. All right, I'm gonna switch to top orthographic mode. That's numpad 7, numpad 5. And then I'm gonna choose Shift A, and then add a curve, a Bezier curve. Yeah, Bezier we'll call it. There's probably a right pronunciation to it. But what this thing is, it's basically a simple graphical way to manipulate a very complex equation. And we're going to use this curve to create the shape of our forest template. Press Tab to go into edit mode, and you'll see here we've got, we can move points around, and we have these little anchors that you can move around that affects the shape of the curve. So right now I'm not worried about the size of anything. I just want to draw out a cool organic looking shape. Start building our shape. All you have to do is select one of the endpoints of the curve, hold down Control and the right click button on your mouse. Sure, your right mouse button, not right click button. Or Control right click, and that's going to add a new point to the curve with some anchors and things. I'm just going to go ahead and keep doing that and draw out a basic shape for right now. So just Control right click around in a kind of a circle-ish looking thing. That's pretty good. And then now I'm ready to close my curve off. So I want to hold Alt and C, and that'll close the curve off. Now let's go back and click on the various points of the curve here. You can press G to move them around however you wish, and just kind of refine the shape of your object. And then also click on the various anchor points. So you have the actual point of the curve in the middle, and then you have two anchor points. Click on those, press G, and that changes the shape of the curve. Now, it doesn't really matter exactly what the shape of your forest template is. What you need to do though is avoid looping over yourself. So don't do something like this, where you can see I've got the line going through here, crosses itself over, comes back, crosses itself, comes back over, crosses itself. So as long as it's like this, where it's a continuous path without going over itself, that's all that really matters at this time. And you know what? That looks pretty good to me for a basic forest template. Let me just make it a little bit wider down here. There we go. That's a pretty good little shape. So now we want to turn this thing into a mesh. So left click outside, deselect everything, press A to select everything. So now you've got all the points of your curve selected. Right click and choose Subdivide. And do that several times. This will help give you a little bit of a cleaner mesh when it comes time for 3D printing. Now if I tab out, so I'm out back into object mode, you can see you have the shape of your forest template. But let's see, if we choose Z and we're in solid mode, there's nothing to it, right? It's just a line. So we got to go back in and turn this thing into a solid object. So tab back into edit mode. Actually, don't tab back into edit mode. Tab back out into object mode. And then up here in the upper left-hand corner with our object selected, choose the little object drop-down menu. Go to Convert To and choose Mesh from Curve Meta Surf Text. And what that does, you don't see any difference here. But if we tab back into edit mode, you'll now see we got a bunch of vertices instead of all those little anchor points and curve points. So what we have here is an actual mesh. So now we need to turn this thing into a solid object because it's still just a line. So press A and select everything. Then press F. F will turn it into a face. So you're kind of putting like a skin across this wire structure. However, if we press 1 on the numpad and look at it from the side, you can see that it's still basically zero thickness. You've got something that's got a skin to it, but it's got no depth. So it's still not able to be printed. What we need to do with everything still selected as is, let's press numpad 1 to jump to the side here, actually the front. Press E for extrude and drag this thing up quite a bit. Don't worry about the sizing of it. We'll figure that all out later. And now, if we use our middle mouse button to look around, you can see that we've actually got a legitimate solid object. The last thing we want to do before we start cutting little peg holes for all the trees, with just this top layer still selected, press S to scale and just kind of make the top slope in a little bit. So the top piece, as you can see there, is a little bit smaller than the bottom piece. So we're scaling down the top, and this way it'll give your final piece a little bit of a sloped edge to it, which will look a little bit better with the battlefield and also make it so miniatures can kind of stand on these sloped edges instead of just being like a elevated piece of something. It just makes it, the whole battlefield look and interaction with the miniatures just better. All right. Now at this point, we need to start thinking about the size of the object. Tab back into object mode. Let's go 7 to our top view and press N on your keyboard. And what that's going to do over here is bring up a whole bunch of numbers. And this is all about sizing and rotation of this object. And what we're going to be interested in here is looking at the X, Y, and Z values. These are the dimensions. Don't change the scale, change the dimensions. Even though they say they're meters, what this really is for 3D printing purposes is millimeters. And so a 10 millimeter by 6 millimeter by 1 millimeter object is really, really tiny. That's like ½ inch by ¼ inch by really tiny. So let's imagine that this thing is going to be 6½ inches wide. So let me bring up a calculator. Now there's 25.4 millimeters to an inch. So 6.5 inches times 25.4. 165 millimeters. So let's go back to our X dimension and punch in 165. Now it's just really long and stretched. For the Y, let's make that be 4½ inches. So we're going to have a little bit of a different aspect ratio, but that's fine. 4.5 times 25.4, that is 114.3. So let's go 114.3. So there we go. So now we've got something that kind of looks like a cool forest template shape that you might see on a battlefield. And we're now about 6½ by 4½ inches. Z is how thick it's going to be. About 3.5 millimeters. That's about 1/8 of an inch. So I think that's what we'll go with. But let's just confirm that. 1 divided by 8 times 25.4. 3.1 millimeters is 1/8 of an inch. And that'll probably be pretty good for our purposes. So you can see now here, this is looking more like an actual template piece that you would have sitting on the battlefield. Now we need to cut all the holes for the trees. So now we need to measure the pins of the trees. And this is where you get to learn about how bit of a disorganized life that I tend to lead. I just got up to go get the calipers that I'm going to use to measure this because I knew where the case was. Well, I opened the case up, and it turns out, well, they weren't in there, which is a kind of unfortunate. Because, see, the calipers were sitting right in front of me on my computer desk, staring right next to me. Because, you see, the calipers were actually on my computer desk, right next to my microphone pack that I'm talking to you in right now. Okay, so let's see. We have one of the Woodland Scenics Trees here. Now the pins are about 1½ millimeters wide. And let me actually see how tall they are, because this does kind of matter. Oh, you know what? Okay. So the pins of the trees are 1.5 millimeters wide, but they're about 6 millimeters tall. This is important. So we do need to bump up the height of our template here. So let me change this to 6.1. So it'll be about 1/4 of an inch tall instead of a 1/8 of an inch. Then that's to accommodate the trees themselves. Okay, so now we need to cut some pin holes in here. I'm going along here, just rambling along. Press this button, press that button. Now I always forget to tell you guys to save. So go ahead, save it out. And now we're going to start adding some peg holes for the tree. So Shift A, choose Mesh, Cylinder. I bet if I press Z and choose wireframe, there it is right there. Down in the left-hand corner of your screen, choose the Add Cylinder button. For the radius, we want to add, this is where things get a little tricky, because 3D printed holes tend to be a little sketchy in being the exact size. So what I think I'm going to do is make them be 0.85 millimeter radius. With a 0.85 millimeter radius, that's going to mean the holes are going to be mathematically 1.7 millimeters in diameter, which is a little big, but 3D printed holes always come out a little bit small. It's quite possible, though, that when this is all said and done with, we're going to be using a drill to drill out these holes. For the depth, let's set this thing to 10. It's just got to be a number greater than the height of our stand, which is 6.1. For vertices, they can crank this sucker up to like 64. It's not really cranking it up, but you know how that goes. All right. There it is. Okay, so here is a representation of our peg hole. I'm switching to either the front or side view, and then press G and Z, and align it such that this cylinder goes all the way through our forest base. So you can see here the bottom of the forest base is right here, top is there, a little bit is sticking out on the top and the bottom. And what I'm going to do now is just duplicate this thing several times and maybe put like 10 or 15 pegs all across the surface. So Shift D, move it around. And this way it just gives you plenty of spots. Whoops, where'd that one go? Undo that. This will just give you plenty of spots then to stick trees into the base when you're ready to play a game. Now we have a bunch of the pegs here, but we actually got to cut them out of the base. So I need to select all these pegs and then do a Boolean operation, which, oh dear goodness. I still have nightmares from that from years of pre-2.8. 2.8 seems to be doing better with Boolean operations, but it's going to fail on me one of these days, and today just might be that day. So let's select all these pegs, and how we're just going to do that, let's do B for box select, select everything, and then Shift left click on the tree base or the forest base twice, and then that will deselect it. Now Shift left click on one of the pegs and hit Control J to join them all together into one object. Now over here on the right hand side, I have this object tab selected, which is basically the box with 4 little angled corners around it. This is object properties. I want to rename it from cylinder.someNumber, because it's going to vary depending on which one you selected a moment ago, to trees. And then I want to click on the base, and let's go from Bezier curve to forest base. I'm just doing that to make life a little bit easier here in a moment. Let's Control S, save, and then on the right hand side, choose the little wrench, that's modifiers when we have the forest base selected. Choose Add Modifier, Boolean. Now a Boolean operator is a way of mathematically taking 2 3D objects and doing some sort of math operation with them. In this case, we're interested in the difference, which is going to take a base object and essentially subtract away the volume taken up by a second object. This is a very complex mathematical operation, and that's why it has a tendency to fail horrifically. But let's see what happens. Blender 2.8 is doing better, but it's not a guarantee. So make sure operation is set to difference. If not, just click on the drop-down box, choose difference. For object, we only have one other thing available, which is trees, so click on that. And now you can kind of see it's starting to do what it's supposed to. It's looking pretty good. Because what you can see here now is around each of your tree pegs, the top and bottom are black, and the middle is orange. That looks to be a good, clean cut going between each of the things. But we won't know for sure until we go ahead and apply the operation. So we hit apply. Then let's click on our tree object, our trees here. If I press H, that just hides them. They're still living up here. We can come find them later, but they're just no longer being displayed visibly. And now clicking on our forest base, press Z, choose solid, and just kind of zoom in and look in each of these holes and make sure things look all right. And they actually do. I don't see any weird floating edges or faces that don't seem like they belong. Each of these holes has walls to it. Oftentimes one of the ways Blender 2.7 would choke and die is you would have a top hole, a bottom hole, but there would be no walls connecting them from the top to the bottom. But all in all, that looks pretty good. So we've got a basic shape of a forest base along with, pegs for a bunch of trees. This is pretty much what we need to do in terms of modeling. This is a very simple little tutorial to show you guys how to use some of the cooler aspects of Blender and just do, really simple terrain with them. So let me save this and then we'll export out to Cura. So for that, File, Export, STL file. Let's just call it Tree Base. Export STL. We don't really need it now. Actually, we do need it now. Always under Export STL, always choose Selection Only. Bad things can happen if you don't. What it'll do is it'll export your entire model, which is usually not what you want. So if you have other pieces floating around like those little trees, we don't want those coming out. Everything else here, just keep it the way it is. Hit Export STL, and now we jump over to Cura. Here we are inside Cura. I got my 3D printer stuff loaded up in the background. Let's open up our model. And let me make sure I'm not using black TPU 95A like I have been using. Just some generic PLA is perfectly fine. 2 hours and 5 minutes. All right, let's get this sucker started and see how things go from there. Oh, before I start printing, always do solid view. Let's choose layer view. This is going to let us see the 3D print be reconstructed layer by layer. And this way we can often see any errors in our model will show up here, but that looks exactly how I would expect it to. So while the base is off being 3D printed, let's work on some of the trees. These are just the Woodland Scenics Realistic Tree Kit, and I'm following the instructions on the package with a few little bonus tips from Luke Towan, who's one of the very popular YouTubers when it comes to making basically realistic dioramas and train setups and things like that. I'll put a link to all his videos in the show notes of this one if by some chance you're watching me and don't know who he is. Off camera, I'm hitting these trees with a little bit of spray adhesive. Here's our 3D printed forest base. Now comes the moment of truth to see if the size of the holes worked out as expected. Let's get my hand out of the way. No, they didn't. 3D printing these tiny holes like that is going to be a little sketchy. So unfortunately, going to get a little bit of help from our friend DeWalt and drill these holes out. To get a 1.5 millimeter hole, you'd probably want to use the 1/16 inch drill bit. But to give myself a little bit more wiggle room, I'm going to go with the 5/64 drill bit, so it's a little bit larger. Now, if you're wondering, because of the fact we had to go back and drill out all the holes with a drill, why do we put them in the 3D model in the first place? There's actually a good reason for that. The way 3D printers work is when you actually put a hole in the model, it draws several lines around that hole, which gives you a little bit of extra material to drill through, but also makes the walls of these holes a little bit stronger than if there weren't any walls there to begin with. So by having those holes in the 3D model, it actually makes the drilling process go a little bit better and gets you a little bit better result. Ideally, we wouldn't need to do that, but whatever, it happens. Okay, the last step is I'll just paint and flock this thing as we would any normal terrain piece. Hit this piece with some filler primer as well as a sandy color I had laying around. Now you can still see the 3D print lines in quite a few spots, but I'm not too worried about that because I'm going to be flocking the whole thing and that should cover up those visible print lines. So at this point we're pretty close to the end, but you'll notice we got a small problem here in that by applying all the flocking, well, where are the tree holes? To solve that problem, I'm going to flip over the template on the back where we can still see all the holes and just going to use a pin and do your best to kind of poke it through and clean out each of the holes. Then I'm just going to carefully move away the flocking and other orchid bark that's right around each of the tree holes, just so they remain a little bit visible. Well, the base is dried enough for me to move on to the next step. I've kind of screwed things up a little bit handling it, but let's be honest with you. If you're the kind of person who gets a little uptight about your tabletop wargaming stuff getting damaged, perhaps you should try model railroading instead of games that involve moving around your fancy terrain and miniatures and stuff like that. Just trust me on that one. All right, so anyway, got a bunch of little peg holes in here. Let me go ahead and start inserting the trees and see how it looks when everything's all in place. Now that is looking pretty cool. So I've done a nice job here with the 3D printed base. And as we stick our miniatures into the woods, we can go ahead and remove the trees and put them in as necessary. So awesome, I'm liking how this turned out. Now of course, this type of terrain build we just did with Blender can apply to other types of terrain as well. Just go ahead, what you gotta do, make it a little bit bigger, kind of maybe raise the elevation up a little bit, and you got a basic hill. And if you get really creative and try different types of methods, you can build craters this way as well. So thank you guys all for watching. Once again, I'm Jason, the creator of the Tabletop Battlefield. Go ahead and subscribe to this YouTube video to get more random things like this, like Blender for tabletop gaming, robotics, or like some fun Nerf mods I got planned for coming up this summer. So thank you guys all for watching, and have a great week.